Good afternoon. Did you guys have a good spring break? Too short, okay. I see some people that aren't too sure, or they don't look too sure if they have a good spring break. Well, it's good to see all of you back. Glad you're here. Today we're going to wrap up our discussion of assemblies and drawings in SolidWorks, and we're also going to show you how to take your model and save it into a format that's suitable for 3D printing. So you can actually read it to the 3D printer and print it out of plastic or even metal. So let's start by going over sort of the requirements of this week's homework assignment. You're going to be working with this telescope assembly, and first of all, you're going to recreate the telescope mount from the given parts as shown in the picture above. So I've given you all of the parts for this assembly. All you have to do is download them from D2L, unzip them, and then you can put this together. This only requires the standard makes like you've used for 2 weeks now. You don't even need the mechanical makes like we did last time to put this together. It's just standard makes. There's nothing new in putting this together. Okay, so once you put this together, you will then use your assembly to create the drawing that's shown in the telescope.pdf. So that is also on D2L, and it looks like this. It's a 3-page drawing. This is the first page. It's just got our standard views, an isometric view. The second page looks like this. We've got an exploded view of the telescope. We've got this bill of materials table. And then the third page looks like this. It's got some supplemental views and some additional stuff that we'll talk about later. So that's the drawing that you will create. And in a minute, a little bit later today, I'll show you anything that's new in that drawing. You're going to create 2 different telescope configurations within your assembly. One for direct viewing and another one with a given Canon 7D camera mount. You will need to adjust the parts to let the camera mount version pivot a full 360 degrees in pitch. So we'll talk about why that is and what that involves a little bit later today. Then you're going to take your assembly file and save it as a single part file, showing the camera version of the telescope mounted in a particular orientation. And then finally, you're going to take this solid part file that you've created, and you're going to save that as an STL file. That's the file type that we can 3D print from. Okay. Now, what you're actually going to turn in this week, you don't have to 3D print the telescope. You could if you wanted to, but what you're actually turning in is your recreated PDF of the telescope drawing, that 3-sheet drawing that I showed earlier. You're going to turn in your solid part file. So when you save this as a single part, you're going to turn in that file showing the telescope pointed straight up. This is the solid part file, not the assembly. And then you're also going to turn in the STL file that you create with the telescope pointed just like it was in item number 2. Okay, and it says to set the STL units to millimeters and fine resolution. Okay, and then that'll be due as usual before your next week's lab. So, because there is nothing new in putting that telescope together, I went ahead and put it together just to save us some time. Again, this was all put together just using the standard makes. And when you have this put together, there should be 2 degrees of freedom of motion remaining in the assembly. The telescope should be able to pivot back and forth this way. And then also, if I temporarily fix that motion, we should be able to adjust the elevation angle of the telescope and make it point more up or more down. Okay? Now I'm going to unfix the pivoting motion there. Choose float. Okay, so view of this assembly. Okay. And I looked at a top view of the view in the drawing. In the top view, I'd like the telescope pointed straight down toward the bottom of the page. So in my assembly, the easy way to achieve that orientation is simply take one of the side surfaces and make it parallel to the right assembly data plane. So let's do that real quick. I'll make that surface to the right data plane and simply make those parallel. Okay, and now if we look at the top view of our assembly, okay, it is pointed downward on the page like we want. Now, one of the things that you saw in the drawing I showed earlier was an exploded view of the telescope assembly. And we defined the exploded view not in the drawing, but actually in the assembly file itself. So that's the first thing we're going to take a look at here. In our assembly file, to define the exploded view, we go on the assembly tab, we go over here to this exploded view button. Okay, we click that, and we can click on a component in our assembly, and it's going to give us these handles that then allow us to drag that component to a new position or new orientation for our exploded view. So like I can just click on this arrow and drag that side support out to the side, then I can click on this side here and drag it out to the side, do the same thing, the other side, drag those back. And let's go ahead and drag this faceplate down a bit. Now, what I'd like to do with these holding rings is drag them along the telescope axis, so at an angle like that way. And if I click on the holding ring, you'll see it doesn't give me a handle in that direction. I've got one going straight horizontal or straight vertical, but I don't have one at an angle like that. So what we can do is, if we right-click on the dot there at the center of that triad, if we right-click on that dot and say Align To, we can then click on other surfaces in the model, and when I click on a surface, the triad will reorient so that it's parallel and perpendicular to the surface I clicked on. And by doing that, we now have a handle that's at that angle, just like we want, and we can click and drag that holding ring up to the front. Okay? And I'll do the same thing for this backwards. So I'm going to click on it. In order to get the handles reoriented, I'm going to right-click on the white dot, the origin, Align To, click on that front surface of the holding ring, and then I've got the handles oriented to where I can just drag that back. Okay? Now, you may have noticed each time I drag one of these components, SolidWorks was creating the explode step for that movement over here in the properties box. If we want to readjust the position of one of our components, we can simply go back to the explode step, select the component wherever we originally defined it, and then we could modify the component however we want to. We just modify that explode step. Another thing, you don't need to do it here, but if you wanted to rotate one of these into a different orientation, you can just click on the component and use the curve or the circular handle, so like you can pivot that out to the side to adjust the orientation or the angle. But we don't need to do that for this assembly, so I'm going to go to that explode step that I just created and right-click and say delete. Okay? Now, if you wanted to position components really precisely, you do have the option to actually type in numerical distances or angles, so you can be very precise. But again, you don't need to do that for this homework assignment. Just drag the components so that they look similar to what you see in the PDF drawing. Okay? Okay, so that's how we define our exploded view. I'm going to click the green check mark. Now, if we want to show this all put back together, or if we don't have to go back and recreate all of our makes, we can just right-click on the exploded view and we can choose collapse from the menu. So click collapse and it all goes back together. Now, these two conditions of our model, the exploded state and the collapsed state, are saved as different configurations of our assembly. So in our model tree, we've been used to looking at this first feature manager tab here, but there's other tabs, and the third one over, this one in the middle, is the configuration manager. If I go to that tab, you can see here's our assembly model. We have this default configuration, and if I expand that, within that I've got the exploded view, and I can expand that and see all the explode steps that I just defined. Okay? So if we want to re-show the exploded view, we can do that just by right-clicking on our exploded view here in the configuration manager and say explode, and it puts it back in that condition. Now, another cool thing that we can do is if we right-click on explode view 1, we can say animate collapse, and SolidWorks will actually create a movie file. In this case, it's reversing the explode steps, but it's putting the telescope back together, and we could save this animation as a movie file, as an AVI file, if we wanted to put it into a PowerPoint presentation, or maybe we need to email it to a customer who can't figure out how to put our assembly together, or whatever you want to do. It's an easy way to create a movie file that you can take outside of SolidWorks and show how your assembly goes together. And if your assembly is put together, you can right-click and say animate explode and animate those explode steps that are being taken apart, and you could likewise save that as an AVI file if you wanted to. Okay. All right. So let's see. I'm going to collapse it again. Do you have any questions about anything we've done so far with our exploded view? Questions? Okay. So one of the things that you're asked to do this week is actually create two versions of this telescope assembly. You're going to create two different telescope configurations, one for direct viewing and another using the given Canon 7D camera mount. So let's talk about that. Okay? You've got your assembly file that you put together, and this one I would consider, this is like the direct view version, because this has the eyepiece that you would put your eyeball to and directly look through the telescope. And this is currently our default configuration, because this is the one that I put together first. First of all, I'm going to rename this default configuration. I'm just going to click on it and then click on it a second time. I'm going to call it direct view. Now, we have a second version of the telescope that we would like to put into this assembly and be able to quickly switch back and forth between the two versions. So we're going to do that by creating a new configuration of this assembly. And to do that, I just right-click on this top-level assembly file and say Add Configuration. And it'll just be type in a name. I'll call it Camera, because this will be the camera view version. There's other options that you can play with. We're not going to change any of the other default options. I'm just going to accept that. Okay, so now my camera configuration is added to this model tree. And what I want to do now is bring in that alternate version of the telescope. So I'm going to go to Insert Components, and if I browse, let's see, this folder. Okay, so in the parts that I've provided you on D2L, you've got the Meet 8 telescope. That's the one that's currently shown. The Meet 8 telescope with Canon 7D is the camera view version. So I'm going to click on that and insert it. Okay, there it is. And I want to replace this direct view telescope with this camera view telescope. So I first need to get rid of the direct view telescope. I don't want to delete it though, because I still want it in this direct view model. Instead of deleting the telescope, I'm going to right-click on it and choose the button that says Suppress. Suppressing a part is a way of hiding it from your model without deleting it from the file. So now I'm simply going to make this version in its place. So let's go to Make, and I'm going to click on that front surface, front face, and mate it with the front face of this holding ring. And I want those to be offset by 3 inches. And I want them to point in the same direction, so I'm going to reverse the make alignment. Okay, so I'll accept that. surface of the telescope and the curved surface of the holding ring to make those concentric. And at this point, the telescope's in the right place, but it's still free to pivot, like around its own axis. So to fix that kind of motion so that it can't spin like that, one way we could do that is just make like one of these flat surfaces of the camera. So this box back here just represents your camera, or the volume of space that would be occupied by the camera. So we could click one of those flat surfaces and made it parallel with one of the cutout surfaces in the holding gear, or the side gear. And just make those parallel. And that way the telescope won't be spinning around its axis anymore. Okay, so this now is going to be our camera view configuration of the assembly. And if I double click to switch back on the direct view, it currently has both telescopes in it. So we need to suppress the camera telescope from this configuration. So just right click, go to suppress. Okay, so now here's our direct view configuration, and we can quickly switch back and forth just by double clicking on the other configuration, whichever one you want. So being able to save different configurations in one assembly file is really nice, because you don't have to create a different assembly file and you can go with all that other stuff for every different version of your assembly you want to show. You know, you might have an airplane model and you want to show one configuration with the landing gear up and another one with the landing gear down, or flaps up and flaps down. This saves us from having to produce a bunch of different assembly files. Okay, so that's our configuration. Now I'm going to go back to the first tab, the Feature Manager tab. And notice if I drag this so that it points more and more up, okay, at a certain angle, we have a problem. Okay, that camera is just going to bang right into the bottom plate, and in the model it's trying to just pass right through it. But we have an obvious interference problem here. So the next thing we're going to do is fix that. Now in this case, the interference is pretty obvious, right? But you might have an assembly where components are moving close to one another and you can't tell if they actually collide or not. So here's a tool that can help you detect interferences. If we go to the Move Component button, we've seen this before. Last time we did physical dynamics, right? You remember that? We dragged one gear and it caused the other gear to turn. Okay, the other option we have is this collision detection. So if I choose that, and I'll go ahead and check between all components. And I'll say stop at collision and highlight faces. Okay, so if I click on the telescope and drag it now through its range of motion, I'm just going to click and drag that side gear up and down. Okay, when it detected that collision, the motion stopped and it highlighted those faces that were involved in the collision. And I don't know if you heard it, but it also played a sound like it was kicking an empty trash can or something. But anyway, I'll drag it again just so you can see. So drag it through its range of motion. Okay, and as soon as it detects the collision, the motion stops and it highlights the faces to alert you that there's an interference problem as you the base. Now, as soon as we close this box by clicking the green check mark, SolidWorks goes right back to its previous behavior of not caring about interferences. But at least now we know we've got a problem to fix. Okay, so to fix this problem, one way we could do it is make these side supports taller, right? And of course we could open this part file, modify it, and we know that when we resave it and then come back to our assembly would automatically update, right? So that would be fine. But I want to show you, you can actually edit your parts right in your assembly file, okay? So if I want to edit this side support, you can right click on it and go up to the button at the top that says Edit Part. And everything else kind of becomes transparent. The part we're editing is solid and it's shown, everything is blue for that part in the model tree. Okay, but this allows us to work with the part just like you're used to working with individual part files. So we could go to the sketch of that extrusion, we could right-click, go to Edit Sketch, and conveniently, I created a dimension that controls the height of the side support for you. So you can just change that height of 14. Let's just make it 18. Okay. And then we'll accept the new sketch. And I will, when I'm done editing the part, click this button to get out of the edit mode. Okay. Everything else turns solid again. And now if we drag the telescope, we can see we do have plenty of clearance down there at the bottom. Okay? So in your homework, when you're asked to adjust the parts to let the camera mount version pivot a full 360 degrees, that's the kind of thing I'm talking about. You can make exactly the change I just showed if you want to. Just make that 18 inches tall instead of 14. Okay, now, okay, so one of the things I ask you to do is save the assembly as a part showing the Canon version mounted and pointed straight up. So the easy way to do that is just make the back surface of this camera to be parallel with this bottom base plate. So like you would do mate, click on that surface, just make them parallel, say OK, and now the telescope is pointed straight up and showing that there's plenty of clearance there between the bottom and the camera. Okay, so you're asked in your homework to save your assembly as a single part file. And the way we do that is simply go to the Save button and do the Save As. And I'm going to save this to the desktop. We simply change the default file type from the assembly file type, click the drop down there, and choose the default SolidWorks part file type, and with the .slv PRT. Choose that. Go ahead and select the radio button for all components. That way SolidWorks doesn't leave out some part of the model for some reason. And then click Save. Okay, so let me go to the desktop and see. Okay, so this should be the file I just saved. Let me check. Properties. Okay, yeah, that's the .slv PRT file. So this is the file that I just saved. And if I open it in SolidWorks, okay, so you can see the model looks the same, except notice the model tree is different over here. These icons are different. The parts that are in this assembly now are what we sometimes call dumb solids, because the feature creation information that was in them before is stripped away. Okay, these no longer contain the sketches. SolidWorks doesn't know what was extruded or revolved or swept. The dimensions are missing. But that's okay. That's what we want when we save this as a single part file. Now, SolidWorks says, do you want to proceed with feature recognition? If I say yes, SolidWorks will try to reverse engineer this part model and back all that information back out of it. Okay, so it'll try to look at the geometry and recognize what would have been an extrusion, what would have been a revolve. It'll try to put dimensional information back in it. It would kind of undo what we just did. And you don't need to do that. Okay, so when it says, do you want to proceed with feature recognition, just say no. Because for something this complicated, SolidWorks probably is going to make some mistakes, and those cause all kinds of headaches. Okay, so with feature recognition, just say no. And another thing that I'll point out, you saw last week, or maybe the week before, an example of putting a section view, like taking a section view and putting that in your drawing, right? Where you slice through a model. you can actually take section views right in your part file if you want to see the inside of your model. And the way you create a section view in your model is with this view button right here, create a section view. You can click that, and SolidWorks gives you a cutting plane, which you can then drag and slice through your model anywhere you want. If you want to change the orientation of the plane, you can do that. So anyway, if you ever need to see interior features of your model, that's a convenient way of doing it, is just create a quick section view of your model like that. And then when you want the whole model back, just click the section view button again to turn it off. Now, the last thing we want to do with this model is take this version, which is the part file. This is the single SolidWorks part, not the assembly file. We want to take this part file and save it as an STL file so that we could 3D print it. To create the STL file, we again just go back to Save As, choose, let's see, I'm going to save it to the desktop. We'll change the file type again. Now it's the solid part. I'm going to change that to the STL file type, right there, kind of in the middle of the list. And I ask you to make sure it's set to millimeters and fine resolution. So click the Options button before you save it. That opens up these options. So right here are your units, and you can just verify that it's set to millimeters. And then your resolution is right here. So the resolution controls how much deviation from the true shape is allowed in your STL file. Because what the STL file is going to do is take all of this solid geometry and replace it with a bunch of triangles. Okay? And if you choose coarse resolution, a curved surface is going to look more segmented. Okay? Because the coarse resolution allows greater deviation from the true curved shape. If you do fine resolution, it's going to create more triangles to more accurately match the true shape, but you're going to get a smoother curve. And with our computing capabilities today, there's no reason not to do the fine resolution. It's more triangles, but that's no problem. Okay, so I'm going to click OK, which is at the bottom of the screen. I'm going to say, go ahead and save it. Okay, so here's a preview of what the STL file is going to look like. It's just all these triangles, and actually the STL file is just a binary file that lists out the nodes or the vertices of all of these triangles. SolidWorks says it created 14,814 triangles to reproduce this shape. That's fine. We'll just click yes to confirm we want to save it. And here is the STL file that I just saved. Okay, Microsoft identifies that file type as a 3D object, but it is simply the .stl file of our model. So that's one of the files that you'll turn in. Now, sometimes when it creates the STL file, SolidWorks or any other CAD program that you're using will accidentally make a mistake. It will drop or leave out one of the little points or vertices, and it effectively creates a hole in your model. The STL file will save just fine, so you won't know it's a problem, but when you try to read it into your 3D printer, your printer will identify the problem and say it can't print it. And this is something that's a possibility whether you're using SolidWorks or Pro Engineer or CATIA or AutoCAD or any other CAD program. This website that I wrote on the board is a really nice service to be aware of if you're interested in doing 3D printing. Because NetFab is a free service that can fix those kinds of problems in STL files. So it's a free service. All you need is a Microsoft login. But you can take your STL file and upload it to that website, and they'll run it through a bunch of algorithms that find the common errors and problems in STL files, and then you can re-download a fixed version. And we've only used it a few times in this course, because these errors don't happen very often. But the times that we've used it, it's worked pretty well. So if you're interested in doing 3D printing kinds of things, NetFab is a useful site to know about. Now, of course, if you didn't want to use NetFab or it didn't work for you and you encountered that problem, another way that you could try to resolve the problem is just make some slight change to your model. Like maybe change this radius of curvature. Okay, if you make a geometry change to the model, that's automatically going to change, or that will require a different configuration of triangles when you save the new STL file. And there's a good chance SolidWorks might simply not make the same mistake. So changing the geometry works, or NetFab is a good service that you can use too. Okay, so do you have any questions about anything we've done with the model or the STL file before we jump to the drawing and look at anything that's new in the drawing? Do you have any questions about anything we've done so far?
What would happen if you were to save an assembly file as the STL instead of making it part first?
Okay, great question. What happens if I take this assembly file and save it as an STL file? You can do that, there's no problem, but what you're going to get is a different STL file for every one of these components. So you're going to end up like with 12 different STL files. Good question. Any other questions? Okay? So, let's see, I'm going to go ahead and I'm going to close this part version of the file. Done with that. And to proceed with the drawing, I'm going to set the height back the way it was. So I'm just going to double click on that side part and change that dimension from 18 back to 14. And if you ever make a change to your model, like I just did, I changed the height, but the model didn't update. This red and green stoplight looking button is called the rebuild button. The purpose of that button is to force SolidWorks to go back through all the features in your model and make sure everything is up to date. Okay? And you see the little similar icon over here next to those parts. That's a hint that these parts are not up to date. Okay? So all you need to do is click the rebuild button up there, and SolidWorks regenerates the model and makes sure everything's up to date. Now I also want to be able to pivot this back, so I'm going to delete the last make that I created, which was keeping it pointed straight up. So they can pivot again. Let's see. And I'm going to go back to the direct view configuration. Okay, so we're ready to put this into a drawing. We could go up to the new document button and start a new drawing that way. But another option is with our assembly open, we could just go to File and we could say Make Drawing from Assembly. And SolidWorks assumes we want a drawing of the assembly we had open, which is correct. So we need to choose our sheet size. So I'll do A and C landscape. And I do want the title block shown, so I'm going to leave that checked. I'm going to click OK. Okay, and on the first page of the drawing, we've got a front view, a top view, a right side view. So these are the standard views, and then the isometric view over here. We can create those views. Kind of a shortcut for creating the three standard views is to use this first button here, three standard view, or standard 3 view. Yeah, that's the model I want, so I'm going to click the green check mark, and it just automatically throws those 3 views into our drawing. Now, they're a little bit too small because our sheet scale is 1 to 20, and what we want is a scale of 1 to 12. So, do you remember how to change the drawing scale? What would you do? How do you change the drawing scale? Okay,
Then it pops over as well.
okay. So if we wanted to change just an individual view, we could click on it and we could edit the scale of that view right over here. Right here, that's good. However, if we need to change the actual drawing scale down here at the bottom, the way we do that is to right-click, go to Properties in the menu, and that takes us back to this box, and the overall drawing scale is shown right here. So we'll change that to 1 to 12, and apply changes. Okay, so now all the views are updated to match that scale. And let's see, in the drawing that we're creating, we actually want the hidden lines displayed in this view. So I'm going to click on that view and simply change its display style. So I'll turn on the hidden line, or make hidden line visible. Okay. And we also want an isometric view up here. So I'm going to go to Model View, choose an isometric view. We'll make this one a little bit larger. I'll say customs, well, yeah. Let's do 1 to 10 and turn on the preview. Okay, so I'll just click and place that right about there. Let's see. We have a dimension here that includes a tolerance. So if you don't remember how to do that, tolerance, remember you just do the dimension the normal way. So I'm going to click, whoops, click the wrong thing. Smart dimension. Okay, so there's the nominal dimension, and then when you click on the dimension, you can come down here to the tolerance and precision section, and that is what's shown in the drawing is a symmetric tolerance of plus or minus 0.05. So just type that value in the properties box. Okay. So that's how you change, or that's how you show a dimension with the tolerance. You're also asked to put your name in the title block. Do you remember how to edit the title block? How would you do that? How would you put your name in the title block? Well, you could add a node and type over the title block, but if you want to actually type in the title block, you could right-click and remember you need to go to Edit Sheet Format, okay? And then click in the box and type your name, type whatever you want. Yeah, just type in there and then click this button at the upper right when you're ready to accept it, okay? Okay, do you have any questions about anything you see in sheet 1 before I go to the next sheet? Okay, this one's mostly review on sheet 1. So sheet 2 is where we have the exploded view and we've got this table. So first of all, to create another sheet in our drawing, and this is an easy 5 points on the next exam, because I always ask you to create a multi-page drawing on the second lab exam. You can either right-click on sheet 1 and choose Add Sheet, and that gives you sheet 2. Or the other way you could do it is just click, kind of like you do in Microsoft Excel when you want to add another worksheet. You can just click down here on this Add Sheet at the bottom of the screen. But we have sheet 2 now, and I want to turn the title block off of this sheet. So right-click, go to Properties, and simply uncheck the Display Sheet Format box. Okay, and now if we go back to sheet 1, it still has, the title block and everything in sheet 1, but sheet 2 doesn't have the title block, so we've got more room to show our exploded view. Okay, so we're ready to insert the exploded view that we defined for our model. And on the View Layout tab, we can do that by going to Model View. That's our model. Click Next. We want assembly model we want to display. So we can either do the camera view, or we can do the direct view. And when I choose direct view, then it gives me a checkbox that says show an exploded or model break state. Okay, so I can click that checkbox, and that will give me the exploded view of the model. Now notice that checkbox goes away when I switch to the camera view, because the exploded view was only defined for the direct view version of the model. So when you're creating your exploded view, you're going to want to create that for the camera view version rather than the direct view, because the exploded view doesn't automatically copy to your new configuration. But I have an exploded view of the direct view model, so I'm going to choose that configuration. I'm going to click the checkbox to show it in the exploded state. I'll just click right there, and let's go ahead and make it larger by changing the scale to 1 to 10. Now, you'll notice that what I have is pointed in the wrong direction. This one points off to the right. My telescope is pointed off to the left. So a neat thing that you can do in your drawing view is use this button that says 3D drawing view. Well, it doesn't say rotate, but this allows you to rotate your drawing view just like you're used to rotating your model. So if you click this 3D drawing view button, it says select the drawing view, put in 3D mode. Okay, so I'm going to click that view, and then you just use the middle mouse button and rotate that view around just like you're used to rotating your solid models. Okay. I'm going to click the check mark and drag it down a little bit. Okay, so that's how you can reorient your three-dimensional model in a drawing view. Now we also want that table up here at the upper left corner. So the table that lists the components and their quantities, that's called a bill of materials table. And we can create that by going to the annotations tab and coming over to the tables button at the very right. There's all kinds of different tables that we might want to put in our drawing. Weld tables, revision tables. This one's the bill of materials. In industry, they may refer to this just as the BOM. Sometimes they just call it BOM for short. I remember when I started working at Sandia as a new engineer, one of my first jobs, or first tasks, was I was working in this satellite design group, and one of the senior engineers came to me and handed me this big set of drawings for a space satellite and said, I need you to create a bomb for this satellite. And I thought, that sounds fun. We're going to blow something up. But he was referring to a bill of materials table, which means I had to go through and list every single component in that satellite, and there were hundreds of them, and the part numbers and quantities, and that wasn't any fun at all. But SolidWorks makes this very easy for us to create a bill of materials table. Just go to Tables button, click Bill of Materials, select the drawing view, so just click on that view. And there's a lot of different options for controlling exactly what's in the table and how it looks. Don't worry about changing any options. Just go with the defaults. Click the check mark, and SolidWorks automatically creates the table for you from your assembly model, and you just click wherever you want to place the table in your drawing. Okay? So it automatically, and based on the part files, it's identified the part name or the file name as the part number, but we could change all that back in the part files. And then you can work with it kind of like in Excel. If you want to resize the columns, if you want to change like the title, if I just want this to say quantity instead of direct view quantity, I can double click in that cell and I can edit the text there. So that's how you create a bill of materials. It's like 2 steps. And I guarantee you this will be on the next exam. So remember those 2 easy steps, because that's an easy, probably 10 points on the exam. The other thing we need in this view page is the balloons that identify the different components with numbers to match the bill of materials table. So that also is very easy. We can just go to Auto Balloon right here on the Annotations tab and click on the view. SolidWorks gives us all the balloons pretty much automatically again. And again, don't worry about changing any of the options. The default options are fine. Click the green check mark, and then you can click on these and drag them around and reposition them. And the numbers in the balloons automatically will match up to the bill of materials table. Okay, so like this is component 4, which is the side gear. And just to show you how smart SolidWorks is being, if I click on that balloon and drag its arrow to a different component, like I'm going to drag it to this part, the number in the balloon, notice currently it's 4. When I release the arrow there, it automatically updates to be 5, the holding ring. So it's keeping the balloons consistent with the table. Okay? So SolidWorks is doing us a big favor there. But anyway, you can drag the balloons around, and by default, SolidWorks is not going to put duplicate balloons. You know, like we've got 2 of the side supports, it only put a balloon on one of them. So to fill in the missing balloons, just use this other balloon button to manually create balloons. So click that, click on the component, and then click to place the balloon, and SolidWorks fills in the number automatically. And we've got the same thing for the holding ring. That one got a balloon, this one did not. You just click on it and click to place the number. Okay, and the side gear too, that one. Okay, so that's how you fill out the balloons. Do you have any questions about this sheet of the drawing before I show you the third sheet? Okay, so this is the third sheet. We're going to start with a top view up here. So I'll go to Add Sheet. I'll turn the title block back on. And I'll do a model view, do a top view. Put it right there. And let's see, I'm going to change that to 1 to 10. Okay, now when you place the top view, notice what we want is a view pointed off to the side, and it's giving us a view pointing straight down. So another useful tool is this button right here, which allows you to two-dimensionally rotate a drawing view. So we can use this rotate view button and select that view, and then we can rotate it by 90 degrees to make it point off to the right like we want. We want to take a section view through it, so I'll do section view right there. This, we'll just go straight through the middle. I'll set that, and I don't want to exclude any components, so I'll place that right there. Let's see. Actually, I think I made this one too big. Let me change it to 1 to 12 so that things will fit better. Okay, and then we need a detail view, zooming in on this back end. So go to detail view, just remember you just draw a circle and then click to place the detail view. We can make it larger. The one that we want is scaled 1 to 4. And then finally, in our drawing, we want a view that looks straight down the barrel of the telescope. And this is an auxiliary view. Okay? Now, notice if I try to do a projected view and choose this to project off of, there's no projected view that gives a view looking straight down the barrel of the telescope. So instead, we need the auxiliary view. Okay, you're going to select the reference edge, so that's that front edge. And SolidWorks gives us the view looking straight down the telescope. Like we talked about last time, it's aligned with the view it was taken from. If there's a situation where you want to intentionally break that alignment, you can do that by just right-clicking on a view, going to Alignment, and say Break Alignment, and then you're free to move that wherever you want. And in this case, we need to rotate that just a little bit as a two-dimensional rotation. We just drag it around and make it more or less horizontal. Okay, so there's our auxiliary view. you've got a few dimensions. This is a bilateral tolerance. So when you're creating that dimension and tolerance, choose a bilateral tolerance to put in the plus 0.05 and minus 0.01. Let's see. What questions do you have about anything in this sheet of the drawing? Questions? Okay, so the last thing you want to do is save your drawing as a PDF, and you can do that by going to Save As. It says views need to be updated, that's fine. Say yes. Change the drawing type to, the file type to the .pdf. And again, I'll save it as on the desktop. SolidWorks will create all three sheets in one PDF. Okay, so here's the PDF I just created. It's got all three sheets in it. Of course, if you were wanting to save your drawing as a SolidWorks drawing file, you would also want to do Hack and Go. But you're just going to submit the PDF of your drawing this week. So the closing thought I want to leave you with is when we're creating drawings, SolidWorks is doing the hard stuff for us, right? I mean, it's creating the views automatically. Our job is just to remember where to find the buttons and the commands to get the views that we want. So that's kind of what you want to be doing right now. As you're working on these homework assignments, start memorizing or just remembering where to find those buttons, because on an exam, you're going to want to be able to do that quickly. You're not going to want to be hunting around to find the right button to create a view because you'll run out of time. So that's it for this week. If you have any questions, feel free to come on up.